Today I'm going to talk about deep reinforcement learning for policy agent. In the previous class, I was talking about deep reinforcement learning for value agent. And because of our philosophy is different, our loss function will be different, and gradient descent function will be different. And I'm going to talk about that today. So we have agent, and we have environment. We're gonna apply action, and we're gonna receive the reward. By doing the iteration, we're gonna find the optimal decision. Through this reinforcement learning, we can obtain optimal decision. Of course, in this specific class, we're gonna use deep neural network to represent agent. So if we have state, this agent will produce value function or probability distributions. We're gonna talk about that more details. When we are designing the agent, we can use CNN type network or RNN type network or transformer model. Among many different type of environment, I would say it could be a foundation AI model. It may have certain parameters, including the model parameters and hyperparameters. Sometimes we want to optimize this foundational model, including fine-tuning. We have to optimize these model parameters, and but this reinforcement learning can be used to optimize this foundational model. When we are calculating the reward, maybe computer simulation can be one way to generate the reward. Another possibility is human feedback. If this foundational model gives us good result according to our human ethics, we can give him higher reward. So this kind of approach is called that reinforcement learning with human feedback. When we are choosing actions, we can use Monte Carlo method or temporal difference method. Or sometimes we can use online reference, or sometimes we can use offline reference. Sometimes we use exploitation. Sometimes you are using exploration. I think these are the overall picture of the reinforcement learning, especially for optimizing the foundation AI models. Whether you choose different agent network or different environment and different reward, or depending on action choose method, you may have different algorithms. Those are the variation of different reinforcement learning. In the previous class, we was talking about value agent. In those cases, it has deep neural network. If you input the state, you're gonna obtain the value function. So this agent is made of deep neural network, and input will be the state. Of course, this state definition has to satisfy the Markov decision process. You remember that? And once this state and the reward definition meet the Markov decision process, we can apply the Bellman equation. And this network will give you the value function. Value function means your future summation of all the reward. And at those states, if this network will give you the value function, that means among this state, you can choose action that give you the highest value function. So there will be only one state, one action that will give you the highest value function. That means this is very deterministic. This pi means the policy. And we choose loss function as a form of mean square error. Let's assume we have true value and we have output of this deep neural network. We are going to train this network so that this is going to be equal. This V theta is DNN output. This V true will be obtained from the experience. Sometimes we can use Monte Carlo method or sometimes temporal difference method. So main idea of this value agent is you take experience, and at each experience, you compare with your experience of true value with this DNN output. You train this network with model parameter theta until this 2 is becoming minimal. In the Monte Carlo method, this experience is represented by GT. In the Monte Carlo method, how are you going to obtain GT? You generate the episode by choosing different online and offline reference, and by applying exploitation and exploration, you can choose certain episodes, and you go to the end of the episode. And if you go to the end of episode, you can make all the summation of the word. That's gonna be the return. And that is the true value of the value function of state S. In the case of temporal difference method, it's gonna be you just move one step, that is gonna be reward by a step, and V theta st plus 1 is the future reward. This is the one step future reward. That will be obtained, you just move one step and got reward, and you look at the future. This is the future term, and by adding them, we assume that is gonna be true value of true value. In the case of Monte Carlo method, update equation of this model parameter can be represented by this equation. This is gradient descent equation. You make a derivative of this value function until you reach it to a minimal point. In the gradient descent method, we have minus sign here, but because minus sign is here again, that will multiplication of minus and minus become plus. And the derivative of this equation is changed to gt minus v theta st gradient theta v theta st. This is the vector derivative. So if you are going to use this, one of the application of this value agent is deep Q network. If you select this algorithm for your optimization problem, you can obtain some reference programming from GitHub or some open source software site. And if you choose deep Q network, that means it is a value agent network, and they are going to use this gradient descent equation. So for each time of Monte Carlo method episode, you acquire GT. From experiment, you acquire this GT to return of state ST. This is DNN output, and this is the gradient of DNN output. So you update the model parameter of, maybe you may have millions and billions of number of parameters in this model of CNN and RNN and transformer model. You are going to update those parameters at each Monte Carlo exploration. So Monte Carlo method itself needs a lot of iterations because it has to go to the end of episode. Means at each step, they have to calculate reward. It can be obtained from computer simulation or human feedback. Human feedback is very expensive because you have to hire an engineer or a human, or you have to do the computer 3D simulation. So Monte Carlo method itself is very, very expensive approach. But one episode of Monte Carlo simulation cannot meet all these iterations. In order to, you may start from here, but eventually you have to go to an optimal point. It makes another iterations. And in addition to that, we have billions of model parameters. So reinforcement, because of that, reinforcement learning is very computer intensive, expensive approach. Now, I would like to talk about policy network. This is value network. in policy network, we have input, output is gonna be probability distribution. With a given state, depending on A, it may have different action distribution, whose action distribution will give us the maximum total summation of value. So internally, they have many actions, A1, A2, A3, AN, and this is going to be a certain distribution. So output of deep neural network is going to be probability distribution of action at state S. In the value agent, action is not involved. With the given state, they calculate value function. So we can choose next state who may have highest value. But in this policy network, output is action distribution, action probability distribution. So A1, A2, AN have certain distribution, action distribution, who give us maximum so in the value agent, we want to train this network who give the true value. It is not involved any determination of actions. But in the policy network, it gives us probabilities of action. If you follow that probability action, you may have certain value. This action gives a certain value, this action gives a certain value. So we can calculate the multiplication of probability with value. So we can estimate stochastic value. Here is the deterministic value. If you have a state, you have a single value, but this value is including some action probability. And by multiplying with all the state, it's going to be total probable value function. Here is the single true value. Here is the possibility of all the summation of value. They want to maximize this loss function. And then we're going to update this means we want to find the model parameter theta. This deep neural network has model parameter theta that will give us the total possible summation of value. So it includes, one difference between this value agent and policy agent is that value agent is being trained to give you the true value by applying the Monte Carlo method and temporal difference method. Once you have this policy network based on this value agent network, you can choose an next state who may have highest value. But in policy network, action is involved. At each action, we may have different reward. So total reward means the summation of reward for each action cases make a summation. And in the agent network, they are training this network so that it gives us true value. But in the policy network, they are training this network to give you the highest total value. Philosophically, little bit different. Let me go through some mathematics. Our goal of training is to maximize this total reward, maximize. Our goal of policy network is to maximize the value. Goal of value agent is train this network to give us the true value. Here is the true value. Here is the, let's find out action who give you the highest value. Of course, once we have correct true value, we can choose the highest one. But when we are defining the gradient descent in the policy network, we are going to train model parameter of foundational model that will give us the highest total value. So in order to do that, we have to apply gradient ascent method so that we have to update theta until you reach to maximum point. So at each point, the slope is represented by this vector calculus. If you reach to a maximum point, this gradient will become a zero, so there will be no additional changes. We keep iterations and learning until we reach to the maximal point. In order to do that, we have to be able to obtain this gradient equation. And let me go through this. This expected value is represented by this summation. For each reward, probability of action. If we go to south, east, west, north, we may have different value, and that probability has to be multiplied and we have to make a summation of all the action, east, north, south, west. Same probability is multiplied at the denominator and numerator. And it can be changed as now I would like to explain it. By applying some mathematical derivation, what I can say is that when you are applying the gradient accent, we need a gradient of total value. Total means we have to consider all the actions. Let's assume that you apply the Monte Carlo method, then you can obtain the gain, or sometimes you can obtain one-step reward. This is 1 or 2. In each case, we can obtain this reward. As state as you make an action, then you can obtain the reward, one-step reward or Monte Carlo reward. At that moment, from the deep neural network, you calculate the gradient of log of output value with the given state and action probability. So what you have to do is take an experience of reward, and each case you calculate gradient of log output of your value network, and using this one is what you're gonna have. And this term, so you can do all the cases of different actions and different states. By doing this summation, you can update model parameter theta. Because we don't know what's the exactly action probability or state probability that is unknown, then we apply the Monte Carlo method or temporal difference method, and we take many experience, and that will be replaced by this summation. So in each cases of exploitation and exploitation, you add more and more. That is expected value. And so mathematically, you have to apply the derivative log of this deep neural network output. That is actually action probability. And then you acquire this reward for each experiences. Once this policy network is well trained, we're gonna have action probability. You can choose A1 or A2, depending on your choice. So it's not deterministic, it's more likely stochastic. One of the algorithms that are using this policy network is reinforce. One of the deep neural networks that are based on value agent is deep Q network. So if you are using some software to apply your problem, to solve your problem, if the name of that software is reinforced, that means they are using the policy network and they are using this gradient equation, and you are using some tree method, Monte Carlo method, temporal method to acquire this gradient descent and apply that to make a backpropagation. This equation is going to be used for backpropagation. Here, in this case, we are using this equation is going to be used for backpropagation. So depending on your philosophy, whether you're going to use the deterministic approach or stochastic approach or mixed of them, sometimes you are using offline method or online method when you are choosing actions. You may have different gradient equations. So in each cases, if you look at the papers you have to choose, you will find out what type of equations they are using. One distinction between policy network and agent is that in the policy network, they are using the log of deep neural network. I'm sure it is not easy to understand with your instinct, but if you look at more papers and more presentations, you will be able to figure out what I'm talking about. Finally, at the class today, I'm going to talk about actor-critic model. It has two networks, actor network it is a policy network, and it has critic network. Idea is like this. They are combining policy network and agent network. And when they are using the gradient, their gradient is In the policy network, when they are updating they are applying the back propagation, they have to obtain reward. How did they obtain the reward? They have to design their own experiment, Monte Carlo method or temporal difference method. But it takes long computational time to complete their experiences. Rather than taking experiment, they are using agent network. You have a network that calculates the value. And from this one, you obtain the value. Rather than you are applying the Monte Carlo method or temporal difference method, you look at other reference paper. It's a kind of quiz paper. And you look at them. Rather than having all the iterations of episode generation, and you look at the adjacent network, you are asking, what is good or bad? You are asking to critic network, assuming this is your true. And using this value, you update your action network. Then you can have you will maximize the total value function with a different distribution of action. So the action network and the value calculation network is separated. And sometimes after you have doing all this experiment, sometimes you have to update this critic network. But assuming he is good friend of you or your good academic advisor, you look at them and they will give you you don't need to go all the experiment. And you look at the others, and that is the becoming a critic network. That value will be used to train the actor network. Once this is very well trained, you can determine your action, who may give us the highest value. Thank you for your attention. This may not be easy for you to follow, but this is the end of class today. Thank you.